Yeah, well, I had this dream about, because I'm trying to come up with ideas for this YouTube channel that I'm trying to put together and bringing out the Sutton Cicatrix and what it is. And part of it is mainstream science has just gone off the rails. And one of the things I want to do is, introduce things like these little short news stories like, hey, have you heard dark matter has been debunked? Well, apparently mainstream science hasn't heard it either, but it has. It's been debunked several times by several different people, and it's not
Yeah.
just by fringe people. It's by mainstream physicists, scientists, mathematicians, that there is a huge problem with dark energy, dark matter, and I'm a firm believer that those things don't exist. We don't need them to explain what's going on in the universe. But there's also, science should be teaching us what they think or the information that they have and the way they're interpreting it and some ideas that they have or, this is how we came to this conclusion, but what do you think? And they don't. They say, here's the facts, but they're not facts. They're just somebody's ideas, and then a bunch of people jumped on board and say, okay, we agree with your idea, let's call it a fact. But it's not a fact. They don't really know what's going on in the majority of the physical world. And I know you said you had a friend who is a mathematician, and Wal Thornhill said something once. He said back in, I can't remember the year, but there was a time where physics was done in the lab. Experiments were done. We wanted to learn about the physical world, so we were exploring in the physical world, trying to understand what it is. And then the mathematicians took over, and physics was kind of thrown out, and it's all math now. And the problem with math is you only get the answer from the factors that you put into an equation. If you don't have all the factors, you're not going to get the right answer. And I think that's where we've lost it today is we don't have all the factors. That electromechanical energy or electromagnetism is, what is it? Something like 20,000 orders of magnitude more powerful than gravity. And yet mainstream science has just recently started to admit that there are electromagnetic forces happening in the universe on a large scale. They just say that they don't do anything.
Yeah. And do you think this issue is because of the debate we're having today about how peer review works in science, how it's gatekept, right? It's the
Yes.
gatekeeping they do. And also, I should say science is having and is going through a crisis. During COVID time, this famous meme came, into the mainstream, trust the science, right? And it turns out the science wasn't right. And so there is a lot of issue with the peer review system, the gatekeeping, the people who sort of control who gets into that circle of science and who gets to push science as a mainstream thing. Do you think that has something to do with the problem you are describing?
Absolutely. And it's not a giant conspiracy. There are people out there who say, oh, it's a conspiracy in science to hide things. They want to hide things from the people, from the population at large, because there is some kind of mystical something happening that they don't want anybody to know about. Well, it's not that big. It's basically money. Let's say you are a PhD, you're a physicist who runs a lab, who gets a lot of their donations from, big business people, very rich people who want to see this advance, and they're giving you money. They're giving you lots of money. I mean, look at things like CERN. How much money have they put into CERN? And that was just on a few people's ideas. And the money that we're dumping into these research labs, if somebody comes out from one of these research labs and says, let's say you're this guy, you have this research lab, and you start looking at some alternative theories, Hannes Alfvén and things that he's been doing, and Anthony Peratt, and these people who have been experimenting with plasma physics and have some different ideas about how the universe is put together. And you're thinking, some of their ideas are matching with, things like the James Webb Space Telescope and the information we're getting from James Webb. It's throwing cosmology, it's tearing it apart because, they've got all these predictions saying, we can't wait to get a closer look at this so we can verify. And then they get a closer look at it and it totally goes against the ideas that they had. So if you're that guy and you're going to your investors and you're saying, hey, look, we think we were wrong and we think there's a better way, but we need more money to, kind of take what we have now and move it aside and go this different route. And your investor is
Science
going to
has
look at
become
you
a
and it's like,
business. You're right. Sorry
yeah,
to interrupt. Science has become a business, and we know how big pharma influence the politicians and the policies and the laws. And, like from New Zealand looking into America and the stuff you guys eat is just like, what are you guys doing to yourself?
we're killing
And this
ourselves.
whole, it's this whole make America healthy again movement. I just, in my world, we laugh at that stuff. We're just like, this is, I mean, for for America to be what America is, and the world loves America for a lot of things in terms of like what is achieved. But we look at that stuff, we just laugh, and we're like, "What are you guys doing to yourselves?"
Yeah,
It's silly. It's silly.
embarrassing.
Yeah, it is. I shouldn't brag too much because New Zealand is like the third largest per capita in terms of obese people. So I shouldn't be like celebrating like New Zealand is cool. I think we've got problems too, but we're just pointing out the fact that science has become a business, and I think the most important words we have forgotten in science is "I don't know." This whole idea of
Yeah.
research and looking for new ways of doing things. Yeah, that's definitely the business piece is a big problem. The gatekeeping piece is a big problem. How they do peer review,
Oh, yeah, because
how
not
they
only are
control
you,
Wikipedia. There's lots of academic professors control Wikipedia, and they decide what gets written.
yeah, not only are you trying to save your own funding if you're that PhD, because your investor is just going to say you've been doing this wrong all these years. I've been putting in billions of dollars, and now you're telling me you're wrong. I'm going to go put my money somewhere else. And
It's
everybody's
big
afraid of that, and
business.
that's a real
Big
fear. And
business.
there's nothing wrong with that.
Yeah.
But we need to find a different way, find a better way. And then the gatekeepers, yeah, it's if you're mainstream and you want to go against something, you threaten the rest of the this house of cards that they live in, this massive amount of money that's flowing into scientific research. You threaten that if you go off the rails and want to do something different. So that's
Yeah.
why most of the
Yeah.
people who are doing, vast majority, in fact, I might even say all the people who are learning about the electric universe and trying to come up with different ideas or trying to understand the different ideas that are already out there, you're not mainstream. You're not being funded by somebody. You're a guy
Yeah.
like me who I'm not funded. The only people I'm funded by is the guy I work for, and and I still have a job, but I'm literally, and here's some exciting news. I'm retiring
Oh,
in
great.
about 3 weeks, so
Yeah.
I'm
It's almost like
absolutely
a new
excited
life
about that.
begins, right? A new life begins of different ways of learning, different ways of sharing your learning with people on podcasts or
Yeah,
other blogs or Substacks, right? It's an exciting new chapter for life. Are you excited for it?
I am stoked. Oh yeah.
Yeah. Yeah.
And I'm not one of those guys. It's like, tear it all down. No, there's a lot of
Yeah.
good science out there, and we've done a lot of great things. I mean, we've landed spaceships on comets, so we've done some pretty gnarly stuff.
Yeah.
But even when we land a comet or land a spaceship on a comet, we're finding out new things, things happen that
Yeah.
we didn't expect. And there are other people out there who says, you need to have these different kinds of sensors so when these things happen, you can pick up on them. And they
Yeah.
think that it's not going to happen so fervently that they don't even put sensors out there for it. So
Yeah.
these things are
Yeah.
happening like we don't really know what happened because we weren't measuring the electromagnetic spectrum or whatever it was.
Yeah. So, what are the big myths in mainstream science, as the world knows, that you think are sort of wrong, false, inaccurate?
Redshift, determining the size of the universe and the distance of things by redshift. I think that's got some huge problems in it, and it's still held on to as being you know, the go-to as far as when you want to see how far away something is. You look at its redshift to get its distance. But we've shown many different things where there are two items, one item in front of the other, and the one that's closest to us, because it's in front of the other one, has a redshift showing it's, a billion light years farther away. And yet we know it's not because we can look at it. And they just see these as anomalies. So we don't really know how big the universe is. James Webb came through and they found something that was, 23 billion years old? Well, how can that be if the universe is only 14 some billion years old?
Yeah, but that 14 billion year is based on the Big Bang theory, if you believe in that.
I don't.
Right, well, exactly. I mean, I think you're right. Mainstream will make those concepts as facts instead of those concepts are not proven. Like, no one's proven. I know in Europe they did the whole, circle experiment where they're trying to clash particles to try and recreate the Big Bang, but it's not proven, right? So you can't really rely on those numbers. You can use those numbers with the understanding that these are just theories, right?
Yeah. Yeah, if they came out with that, if they said, this is one way of explaining it, but we really don't know.
Yeah.
And
How big
especially,
the universe is, do you think? Like, if it's, do you think James Webb is sort of closer to the truth than the Big Bang theory in terms of 23 versus 15 billion years old?
I don't think you can put a date on it. I think we live in a steady state universe that is constantly creating and destroying things all over. That there was no beginning of the universe.
Yeah.
That it is something that has been here so long that we can't even conceive of time that would stretch back far enough to show the age of the universe.
Yeah. Yeah. Yeah, it's interesting in terms of these myths. Like I was listening to Elon Musk talk about this idea that we have enough science to do stuff for the next 1,000 years. We don't have to find new science. We don't have to invent these new things. And it's interesting because if you look at Elon Musk's sort of career, he hasn't invented much. He has maybe like 25 patents on his name. So I'm sure he's doing a lot of micro inventions. The Raptor engine for the SpaceX is amazing. He's built a lot of great products, but there's not a lot of like science, discovering new science type thing. Like Bob Lazar, he looked into anti-gravity propulsion systems when he was in Area 51, and he was studying element 115, which is a material used in creating that anti-gravity propulsion system. That took about 25 years for some scientists in Europe to actually put element 115 in the periodic table, that it can be produced, but it needs a lot of pressure, and it's still not easy to produce at scale. Maybe the military does it, who knows, what they can do. So I find that also very interesting in terms of that debate in the mainstream. Like, have we discovered enough science that we can just keep manufacturing and scaling those discoveries, or do we have to go find new science? For instance, in New Zealand yesterday was announced $35 million towards research for nuclear fusion. There's a startup in Wellington. They're working. It's called OpenStar, and that 35 million is going towards that startup to study nuclear fusion. It's replicating how the sun creates energy. So I find that very interesting in terms of do we put our resources towards stuff that we've already discovered and scale those and make them efficient and maximize those outputs for the systems that we all, live with, whether it's productivity, economic systems or financial systems or other things, or do we go find new science? I think that is also a valid debate.
Absolutely. I mean, you said a few things that just want to pull me in a bunch of different directions.
Go for it.
As far as what powers the sun, I don't think it's a flaming ball of nuclear radiation. It's something else. I think it's powered externally with electric fields that are generated or pass through our Milky Way galaxy. So I believe it is an electric sun, and it's, and it would explain why they can't get these these fission reactors to produce any electricity, to produce any energy, because they pump a mass amount of energy into these things, and then they get a massive amount of energy out of it, but they never get more out than what they put in. So I think they're creating something that's more like a battery than it is a generator. It's not going to be generating any power. It's just going to be taking energy from one source, storing it, and then releasing it. So if we can figure out how to put energy into it so we can draw from it, that's going to be beneficial. But we first have to figure out how to put energy into it, where we're going to get this energy, because we can't just generate it and put it in there, because then you're just, generating energy, throwing it into a battery and pulling it out. We have to figure out how to charge that battery freely.
Wow, that's a new one for me. I mean, you're saying that there is some form of other source in the universe that's actually transmitting energy into the sun, which is generating the energy. Is that?
Yeah, I think it's a pinch. It's a like a Birkeland current. It's a pinch that's creating a focus of energy, and the matter that's caught up in that focus of energy gives us the size of the sun, and the amount of energy gives us the brightness of the sun. If you look at the spectrum of the sun and the spectrum of a lightning bolt and the spectrum of a nuclear explosion, the one that stands out is the spectrum of the nuclear explosion, because the spectrum of the sun and the spectrum of a lightning bolt are very, very similar. So how can you get a spectrum from a lightning bolt off of a nuclear reaction? So there's a lot of things with it. I mean, there's the neutrino problem. There's a lot of problems with the sun that it's that they just brush underneath the carpet and say, well, we haven't figured it out yet, but it doesn't mean we're wrong. It's like, well, then
Yeah,
tell people.
I find that very fascinating. Like, we haven't figured this out, but we know how it works. It's like,
Yeah. Well,
explain
why,
that
why
to
don't they
me.
tell people then? Why don't they make that common knowledge? These are the problems that we have. This is what we thought we were
Yeah,
going to find, but this is what we found. And maybe there's
yeah.
somebody else out there who can say, hey,
Mm.
that fits right in here, and come up with a solution for it and give us a deeper understanding. But instead of trying to give people the information to gather a deeper understanding, all we're doing is shoving down the throats of those poor kids in school the facts that are not facts. They're somebody
Yeah.
else's ideas. They're the popular ideas.
Yeah, yeah. I mean, it's fascinating. I've got an 8-year-old boy. He came home one day from school and he said, "Dad, did you know the cars are destroying the planet?" So I was like, okay, that's, I don't have any strong views about that view, but it's like, how did you learn that? Where did you hear about it? What is the view of the school or your peers? So it's very fascinating how that stuff gets shoved down into the throats of these people. But I wonder, I think a lot of governments feel that the public is not capable of handling too much uncertain information. So they have to they have to narrate the information in ways that provides people some comfort and certainty about their existence. I feel that they do that a lot with the public, which I
Yeah, they
I,
do.
I feel is offensive in many ways, right? Because people,
Agreed. Yeah, that's
you
a good
know,
way to put it. I'm
yeah,
offended by that.
yes,
Granted, there's a
yeah,
lot of
yeah,
people out there that can't take that kind of stuff, and there's a lot of people out there just don't want to. Yeah, I don't want to think
yeah,
that deep. I don't want to try to figure that out. I'm running a pig farm, or I'm growing wheat in a field, and I'm an artist where I'm making these magnificent paintings. People are in their own path. Nobody needs to be shoved poor information. Give them proper information, and if they want to dive into it, they will. If they don't, they won't. But just because you don't think that they want it or they need to be assured means that you should shove down false information.
yeah, 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 yeah. Yeah, I mean, I find that very interesting as well. I think there was a guest on Joe Rogan. I'm trying to find his name. He was an actor. He is an actor, and he went on Joe Rogan to explain his theory of physics and how the universe works, and that really exploded, and a lot of people got involved in it to a point that the public facing science figures had to go on Joe Rogan and debate him and prove him that he was wrong. So I found that quite problematic in terms of how they behave and how they try to sort of gatekeep and control and try to break down those ideas. I'm just trying to find his name. It was a very fascinating episode that I would recommend.
Yeah, it's hard. It's just hard. I don't know. I don't even know how to take it sometimes. It makes me so frustrated to see the things that we're doing, and there's no reason for it. It's because, you don't want to hurt somebody. You don't want to have them feel bad. You don't want somebody to feel, you don't want people to feel
Yeah.
stupid, so you don't want to feed them something that's over their head.
Yeah.
That's
Yeah.
wrong. You feed
Yeah.
people and they will take as much as they can take. But
Yeah.
there's a lot of stuff out there that's way over my head, and I watch
Yeah.
it anyway because I'm not offended by that. But when
Yeah.
somebody
So
dumbs it down and tries to tell me something that I know is wrong, that's offensive. And it's not just
yeah.
offensive from, and then I think the part that's most offensive is that other people who normally wouldn't be interested in something like that takes it as fact.
Yeah. Yeah. So I was talking about Terrence Howard. He came on the JRE episode 2152, 2152, where he discussed how the standard periodic table is flawed. He argued for rebuilding it based on natural curves, octaves, frequency, vibrations, inspired by Walter Russell's spiral periodic chart of elements, and tied into ideas about transmutation, geometry, 1 multiplied by 1's 2, or 3 in some context, gravity as electricity-like, and more. And that sort of sparked a ton of debate. And then Eric Weinstein joined him for a debate on Joe Rogan's podcast for episode 2171, where there was a lot of like gatekeeping science community pushback against Terrence Howard's ideas.
Yeah.
And he was mocked a lot by the mainstream media about like this guy's like lost the plot. And he talked about how like he remembered the day that he was born as a baby vividly. So he talked about lots of crazy things on that show. So it really got people going for that episode. So I highly recommend that. Yeah.
Yeah. Remembering the day you were born, wouldn't that be something?
Yeah, that
Yeah.
is bizarre. That would be a bizarre experience.
And then, even the possibility, without going off the deep end, remembering your parents' lives, because you are a creature of your mother and your father,
Yeah.
and
Yeah.
everything that goes to put them together. So you are born with certain abilities that your parents had,
Yeah.
genetics. Why can't
Yeah.
memory be part of those?
Yes, yes, I think it is. I listened to a really good debate about how there is a lot of information in our DNA that we haven't been able to naturally access,
Yeah.
right? And we try to access that information through DMT experiences with ayahuasca, with iboga, natural DMT sort of plants, and one is in Africa, one is from South America. We try to do those sort of things. There's a lot of information, and things like Neuralink, where you can put a chip in your brain now, which is an Elon Musk startup, and it plugs with your brain's electricity and chemicals and starts to sort of make your brain solve this whole memory issue. Like, for example, when we have the invention of the iPhone, humans kind of became a bit slower because we're using our thumbs to communicate, right? We are typing words, right? And in 6 7 years time, we're not going to have iPhones which is going to have apps on it. It's just going to have an AI, and it will predict and understand, and it will do a lot of things without me actually using my thumb. And then the problem still is the bandwidth problem between the smartphone and my brain. So why don't I put the phone in my brain, and it's all of a sudden like symbiotic with my human brain, right? And then all of a sudden,
Cyborg.
memory, we solve memory problems, we can memorize everything, we can tap information that goes back generations. A lot of people find that very freaky,
Yeah.
right?
So my wife and I was just talking about that recently about being able to remember stuff.
Yeah,
I have a real hard time remembering things, facts and figures and stuff like that. You know,
yeah,
I'm
yeah,
63 years old and I still can't do my times tables because I just
right.
it's a memorization thing. And
Yes.
when I was in school or even I some college, but I couldn't remember the facts and figures. I had to learn what it was. And then they could ask me a question about it. And because I knew what it was, I could calculate the answer. Doesn't work for math, so I've never been very good at math, but I am good at, different kinds of math, like fractal patterns and, large math. But basic add, subtract, multiply, and divide, I struggle with.
Yeah,
And facts and figures on things, and I struggle with that.
yeah,
So I want to learn it. I can't just remember it. I have to learn it. And then when I know it, you can ask me anything about it and I can answer your questions.
yeah,
So, but in school, you don't do that. In school, you learn facts, you learn history, you learn, whatever it is, even sociology, you learn somebody else's ideas. And then when you're asked a question on a test, you have to remember what that other person's idea was and what they came up with to be able to answer the question properly. And
yeah,
I remember I picked sociology. Geology is the same. Sociology was great because whenever it came to the test, I got a bunch of questions wrong. And then I
mm,
would take it up to the teacher and I would say, no, my answer is right. Your answer is wrong. I mean, my answer is even more right than yours. And I was able to argue with him why my answer was right. Because here's
mm,
the situation, here's what happens when a bunch of people get together, group whatever, and a question that you asked is answered this way because of these facts. And I was able to, I literally got a 4.0. I got a perfect grade through that class because I never was able to look at a question and say, no, yeah, you're right. I got that one wrong because
yeah,
I learned it. I absorbed it.
yeah.
It fascinated me. But
Yeah, yeah, yeah. I'm with you, man. I hated school when it was like I have to like memorize all these facts and trying to understand how
yeah,
these things like work. But I loved school when it was all about being creative, trying to find solutions, trying to explore. There is no wrong answer. You're trying to be creative with your thinking. I loved school when it was that sort of stuff, right?
yeah. We got to be
And
careful because there still are wrong answers.
yeah, 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 yeah. So
Somebody
what's your
could,
background, Dan? Like, how did you get into all of this? What's your, how did you um,
that's,
started to look into this whole massive plasmoid event at the
that's
end
what
of
kind
the
of
ice
blows me away
age?
because my background is, I straight out of high school, I went into the Air Force. And the reason
Okay.
I went into the Air Force is because I had no direction. I mean, I was busy. I grew up out in the sticks, right? In an area that's got homes all over the place now. But when I lived out there, my backyard was, 10,000 acres of nothing but
Wow.
forest. I
Yeah.
remember old growth trees uh, that were still up on the hill across the valley from where I grew up. And one by one, as I grew up, those trees disappeared. And which is just heartbreaking, even as it was happening. And but that was my life. I was too busy out, riding motorcycles and tromping around in the woods growing up to learn too much about school and what life is. And so when I finished high school, I had no idea what I wanted to be when I grew up.
Right.
And oddly enough, I'm 63 and I still have no idea what I want to be when I grow up. So, but I love the physical world. Growing up in that environment where you're out in the forest, and if you do something wrong, you could get hurt. So you need to know where you are, what's going on around you, and you know, if I pull on this branch and it break, what's going to happen? You know, A plus B equals C.
Right.
So I always had a good real world education on what is physics. You know, I love riding my motorcycle, you know, and motorcycles are all about physics, you know. You go down a trail, you go up a hill, you go off a jump, stuff like that. I used to love to fly on my motorcycle, these big jumps.
Yeah.
And but I was fortunate enough to have a teacher in high school who said, I need some direction. And she pointed me towards the military. And I took this test, I think it's called the ASVAB test, to get into the military. And I got a super high score to the point that I can get into any field I wanted to. So I thought I wanted to be in avionics because I want to learn how airplanes fly. I'm fascinated with flight and physics, and so I want to learn how airplanes fly.
Yeah.
And I went delayed enlistment because I wanted to have my last summer after my senior year, right? So I signed up delayed enlistment to start in October 1st. And when I went to do my physical to take off down to Texas, Lackland Air Force Base, where all the Air Force, everybody in basic training, everybody who's joined the Air Force knows Lackland Air Force Base because that's basic training for everybody.
Okay. In Texas, huh?
In Texas, yeah, San Antonio.
Okay. Okay. Great.
And so I'm going through my physical, and they put me on this light thing, you know, where these circles with a bunch of dots on, you know, like Pollock paintings, you know, and so what's the number? And they're like, I don't see no number on there. I see a bunch of dots. And I turn the page. Okay, can you read any of the numbers on these? I don't know. There's no numbers on those. It's just a bunch of dots. And they're like, okay, well, what about this one? And I'm like, oh, yeah, I can read that fine, and this fine, and that fine. And turns out I have shade blindness between blue and green, which is very common in men. Goes undiagnosed a lot. And if you've ever seen those little circles, it's usually a round circle with a bunch of polka dots on it, and then there's a number within the polka dots. No, there's not. I don't see them. So I couldn't do color vision. I couldn't do anything electronics. So I couldn't get into avionics. And it just broke my heart. So I thought, you know, I'm going to put this in the hands of the universe. And I went in what's called open mechanics. Went through basic training, got out of basic training, and they says, you know, we need sheet metal people, structural repair. So I said, okay, I'll do that. So I became a sheet metal man, you know, aluminum, rivets, fiberglass, boron composites, cables and tubing, stuff like that. Again, it's working with your hands. It's knowing the physical world. It's knowing the properties of things. And after I did my 4 years in the military, Boeing hired me up, and because I'm working on planes, so they picked me up. And after working at Boeing, I was there for about 6 years, and I saw some of these people next to me that they're in their 40s or 50s. They still got 10 years to go before retirement, and they look beat up. I mean, these guys were like, holy cow, you look like you're 10 years past retirement. What are you talking about? And it was common, working on those planes, it tears you up. And I thought, I'm not going to be that guy. So I tried to teach myself computers, and got into, I started building my own computers. And this was back when, 386 and 286 were the big machines. In fact, 386 was pretty much only used as servers and networks because it was so powerful. And long before the Pentium. And so I love building computers, and thought that was going to be the route to go. It was real new, so it was easy to, pretty much do anything I wanted with computers. Got out of Boeing, and I spent probably 5-6 years searching for myself. Went to school for applications, and I learned the Microsoft Office applications. And this is back in Windows 95 and Windows 98. Got a job with Department of Transportation, and funny story behind that. I won't get into it too much, but I got a job because I ran out of gas, and I worked there in fact, I'm still working there. I still work for the DOT. I work for ferries now, but
Yeah.
So that's my job.
Yeah.
But it is not my interest. It pays the bills,
Yeah.
it puts food on my table, and puts gas in my car, and got me a car, but my interest has always been, all the way back when I was in the military, was there are things that are wrong. And I've always looked for things that are just wrong. I had a collection, in fact, I still do somewhere in a box, of bench stock screws that never got, or bolts that never got the head punch, so it's a round bolt. What can you do with that? Or it never got the threads put on, or a oxygen fitting that got the thread machine hit twice, so it's got like crosshatch threads on it or something like that. Things that just made it all the way through the process, all the way through manufacturing, made it all the way out to where it's in a box and we're going to use it on an airplane, and yet it's wrong. So it just made it through. And I love stuff like that, things that are wrong. I got packets of sugar that don't have any sugar in them. I've got, just all kinds of weird stuff. I got a book of matches that have no striker on them. I mean, no, what is it? The stuff that makes a match light. They're just
Yeah.
cardboard sticks.
Yeah.
Because it never made that. So just stuff like that. I was always looking for stuff, and that kind of bled on into learning about physics and learning about science, and I've always been fascinated with just how the world works. So I kind of delved into physics, and the universe at large always fascinated me. Things that we were doing. We went to another planet. We landed on Mars. I was all about that. I just thought it's fascinating stuff. And then I start learning about people who are, and this is before the internet, So I started learning about people who have different ideas, Hannes Alfvén, Anthony Pratt, Manuel Velikovsky, that have some different ideas about how the universe was put together. And that fascinated me. And then when Google Earth came about, I was all about searching the planet. I mean, I thought that was just the greatest thing. I could go anywhere without going anywhere. And the better it got, the more time I spent on it. And that's when I took some geology classes, because I've never really went to college as far as being enrolled in a college. I just took classes of things that interest me. So I took some geology classes, and couldn't handle it because they had ideas about how things were made. How is a metamorphic rock made? The chemical reactions that are happening to make to turn wood into rock. Petrified wood, and I always had questions that they didn't have answers for, and it was just it's not going to be on the test anyway, so don't worry about it. I'm not taking this to learn it to be able to pass a test. I'm taking this to learn something.
Yeah.
And that's one thing that really got me. It just rubs me the wrong way all the way. It says, it's not going to be on the test, so don't worry about it.
Yeah. So how do you get into studying and coming up with the Sutton Cicatrix, and how did you get into actually deep diving into this whole massive plasmoid event at the end of the Ice Age? How do you get to that point?
I've been racking my brain for years now trying to figure out how this all started, and I really can't. And Brian Corey Dobbs asked me, what was the point that I saw a plasmoid taking the shape of a scar on the Earth, and I couldn't pinpoint the exact time that happened, other than just a constant flow of looking at stuff, looking at these mountain formations, the way valleys run, and then also, being fascinated by magnets, so, and then electricity has always mystified me. So I love doing electrical experiments, and I've been knocked on my butt a couple of times across the room, so I have a deep respect for electricity. And putting it all together, gosh, it's just hard to say, but I remember one day, well, I don't want to get too far ahead, but Google Earth. I spent so much time on Google Earth looking at all these things that were wrong, things that geologists could not explain.
Yeah.
The Grand Tetons, the mountains off the Cascade, or the Rockies, the bottom of the Rockies, the Grand Tetons there by Yellowstone and Jackson Hole, and
Yeah.
what created those, and just the way they're saying that it was, tectonic plates being pushed together and pushed up, when right next to it there's this pristine valley you could tell is not being pushed up. It's just, being left alone. How can something less than a mile away being thrust up into the air thousands of feet with these peaks that are just, how can something like that happen? Just literally thousands of feet, not even miles. It's just thousands of feet
Yeah.
away from this pristine valley that you could tell it hasn't really had much happen to it. It just didn't make any sense. Things like that happen. They happen over a wide space. When you take, and I always think about it like a chunk of clay, and you take a chunk of clay and you push it together, you're going to get all this buildup, but you're going to get a lot of buildup. You're not going to get this pinnacle point with nothing happening on the outside, because these forces are happening on tectonic scales, the scales of a continent.
Yeah.
So it didn't make any sense to me. And I came across this guy called Michael Steinbacher, who was talking about mountain building. And he was talking about mountain building through wind, because mountains have leeward and windward sides. And, how can a mountain be created with a windward and a leeward side? Because that's wind, that's not mountain building. And he prescribed to, that was a YouTube channel I saw him on. And the only two channels he subscribed to on his channel were the Thunderbolts Project and Suspicious Observers, which is Ben Davidson's channel, who's now Space Weather News. He's changed it. But I really wanted to meet him, and he was going to go to the Electric Universe conference that the Thunderbolts Project was putting on in 2015. And when I discovered these guys were having a conference, I thought, this is cool, because I didn't know there was other people out there like me. I thought I was a weirdo all by myself. And
Right.
I'm not into social media. I'm not into I have a hard time communicating with people I don't know. So this is new for me, and this is fantastic, and I love it.
Right.
But it's not me. It's not in my history. It's going to definitely be in my future.
Yeah.
So I found this Electric Universe conference, and then I saw the price of the tickets, and then you gotta put yourself up in a hotel, and it was in Phoenix, Arizona, so I'd have to fly down there, and it was like, holy cow, I can't afford this. I work for the government. I don't have a big paycheck. But my wife, the awesome person that she is, she says, you gotta communicate, you gotta connect with these guys. These are your peeps.
Yeah.
You gotta connect
Yeah.
with them. You gotta understand what they're doing, and you gotta go talk to these people. And I'm
Yeah.
like, yeah, we can't afford that though. 'Cause, so
Yeah. I think she's right. I think one of the things I think I appreciate a lot of in the last sort of 10, 20 years is that there's a new group of science community that has come about. And because they've been ridiculed by the mainstream science community, they've created their own little bubble, right?
Yeah.
Graham Hancock on Joe Rogan, lots of these guys have created their own little bubble, and they've created an environment where people like myself join and listen, and that has led into many micro communities around the world of like-minded people that have come together, whether it's events, podcasts, like Brian Corey Dobbs creating this new sort of Mars commission that he wants a lot of people to be part of, and I'm like,
Yeah.
yep, sign me up, because I love everything about that. And as a podcaster, I can contribute. I can get people on the show. I can push your ideas. We can talk about these ideas. We can publish them. I'm with your wife on this one for sure.
So she lit her in. This is for anybody out there who's listening to this, find yourself a woman and be devoted to her. I can't even explain it. She saved me.
Great.
And here's an example: is I came out. We have a little a room off of the bedroom. There's a little room in there where we have our computers and a desk, and I came out back into the den. I sitting down in front of the TV, and I thought, what am I going to do? She comes out of the room with a full page. She says, "Here, I bought your tickets. Get a flight. You're going."
Awesome.
I mean, it was no longer a question. It was, she bought the tickets. Here they are.
Yeah.
Get a flight, get a hotel. You're going, and I did, and it was an eye opener. I had some crazy ideas at the time that I wanted to talk to other people about.
Yeah.
And I was kind of shy about bringing any of these ideas out because they're kind of off the deep end. I had at the time I was working on this theory of how they do megalithic structures, how they put these giant rocks together, so you can't put a credit card between them. After thousands of years, you still can't put anything between them. They're perfectly suited to one another, or perfectly sandwiched together or carved so they fit together. I think I found out how they did that, and it's not that we've lost that technology, it's that our world has changed so we can no longer do it. So we'll never have that technology again unless we're able to do something within the environment that we live in now. But anyway, so I went there, and unfortunately, Michael Steinbacher had cancer, and he wasn't feeling well and did not make it to EU 2015. So I didn't get to meet him, and then went to EU 2016, where I wanted to meet him again, and he was not doing well. In fact, he passed away shortly after that. So I'm very upset with him for passing away without me being able to meet him and thank him for opening this up for me, the way he talked about mountain building, excuse me, and opened my eyes to these bigger things. But I got to meet Wal Thornhill while I was there, and a few people that I met, I talked to some people about this theory I had with how they made these megalithic structures and how they got these rocks to fit together. And I'm thinking, they're going to say, okay, that's a fanciful idea, but it doesn't really work because of the physics, because of this or because of that. And instead, I got this one guy who said, hey, that's pretty interesting. Can I take you out to lunch? And he did. He took me out, and we spent lunch together talking about it. And he says, I've got some real plausible ideas there, and that I should pursue it. And I'm like, well, that's not what I wanted you to tell me. I wanted you to tell me I was wrong and off the deep end so I can move on.
Yeah.
But yeah, so that's something that I'll be bringing out in a future video, is how I think that happened and why I think it'll never happen again.
Yeah.
But I've had some real breaks in life. I've had some, everybody has had some bad things happen to them that turned their life upside down. But at the same time, I've had some real breaks. And one of them was at EU 2016. we had a buffet at the end of it, the last day, the evening, and I just happened, by the roll of a dice, got to sit right next to Wal Thornhill and have dinner, and we chatted for a long time, and he never once shut me down. He gave me some direction, some encouragement. He thought I was on the right path with what I was doing, some of the ideas that I had, and how it goes against mainstream, and that was absolutely fascinating for me to have him, because I have mad respect for Wal Thornhill, you know, and he passed away a couple of years February, and you know, and again, I'm very angry with him for passing away before I could tell him about Cicatrix and what happened there, because I think he would have really been fascinated by that. But he talks about the electric sun, and he opened my ideas about the electric universe and how electromagnetism is the predominant force, and there are things that have happened on the Earth that have been, you know, how do you even describe it? We've had storms on the Earth that are like nothing that we have today. We have lightning bolts that are, you know, mountain building lightning bolts that can destroy an entire area. You know, the Grand Canyon was carved by a lightning bolt. And, you know, that was kind of a hard pill. You know, it's like, that's a bit much. And then and now that I'm looking at it, the Grand Canyon was not only carved by a lightning bolt, but the Grand Canyon is only a small portion of a larger scar. And yeah, just let that one sink in. It's a very small portion of a much larger scar.
Yeah.
And that kind of leads right into where I met Brian Corey Dobbs. Was well, anyway, yeah, that was 2015, and in or 2016, 15 and 16, I got to go to the Electric Universe conference. 2017 was the year I was going to bring out my theories. So okay, I'm just gonna open these up to people there, because I've just been kind of keeping them under my hat, because I thought, you know, they're wackadoodle. But I thought this would be the time to bring out the big theories, you know, and then they had it during the Great American Eclipse. If you remember, the eclipse went full eclipse all the way across the United States. I thought, no, I can't go there. I've got to follow this eclipse. And I ended up finding a place out by Jackson Hole, opposite the valley of the Tetons, where we got to watch, me and a small group of people up in the mountains there, found ourselves up there, and we got to watch the eclipse from that point. And when I looked up and I saw the corona of the sun,
Yeah.
with my own eyes, you could look at that, and if you know anything about static electricity, electromagnetism, electrical forces, and how electromagnetism is one word, it's one force. You can't have magnetism without electricity. You can't have electricity without a magnetic field. It's the same force. And you look up at the sun, and I saw that. I saw an electric field. I saw electrical forces that were driving the power of the sun. And you could even tell that we're looking edge on, you know, because it would look different if you were on top of it looking down on it. But looking edge on, you could see it. And that's when I knew, I said, this is real. This isn't something that other people are having ideas about. This is real, because now I'm seeing it with my own eyes. And so now I'm on fire. Now I'm going to bring it out. 2019, the Electric Universe happened, and they had it in Europe. I'm like, well, I can't go to Europe. That's just too much. You know, so I wait a year. And then 2020, they had it in Portland, Oregon. I can drive to that. So I'm totally psyched. This is going to happen. 2020 is going to be my year. You know, it's going to be my decade. And of course, we all know what happened in 2020. The whole world shut down. The conference was canceled. COVID killed everything. And the Thunderbolts project never recovered.
Right.
They've not had a conference since then. And so all the people I got to meet, you know, Montgomery Childs, who is doing some stuff on the Sapphire project, which is gonna, he's being very careful about what he's bringing out, because the stuff that he has is so powerful it could destroy our economy of the planet. And he is a smart enough man to know not to bring this stuff out, things that are going to change that much, because our economy runs a very delicate balance. But he's doing some pretty cool stuff with the Sapphire project and the people he's working with rather, or that are working for him, because it's his project. Andrew Hall, the stuff that he's talking about, the electric scars, arc blast patterns,
Yeah.
supersonic winds, creating mountain ranges, mountains being built, or material being sorted through electrostatic charges and laying down in these patterns through supersonic winds, creating these arc blast patterns. It's just, he is absolutely fascinating, and he's absolutely brilliant. And I would love to be able to sit down and talk to him about some of this stuff.
Yeah.
Because
Yeah.
his arc blast patterns for mountain building is mind blowing, and he breaks it down to the actual science of what's happening. You know, I look at stuff and I put patterns together, but he knows the science of it. He is brilliant. In fact, I'm wondering, can I share my screen?
Yeah, you can. Yeah. There is a share button. You can click on that. Yeah. With that arrow upwards.
So if I do it. A window, there we go. So this is an image that I got from Andrew Hall of an arc blast pattern.
Yeah.
You can see, I don't know if you can see my mouse on there, but you can see the diamond pattern of this mountain and how
Yeah.
it breaks down into smaller diamond patterns, and then
Yeah.
it breaks down again into smaller diamond patterns, and then again into smaller and smaller and smaller and smaller. Now,
Yeah.
these diamond patterns, or these arc blast patterns, are created by supersonic winds. And when a supersonic wind against a flat surface like the surface of the Earth creates this shock wave, this resonant shock wave.
Yeah.
And the shock wave, not like a dial, like you would turn down a dial, but it snaps to the next level. So as the wind is slowing down, this shock wave, this resonant shock wave, doesn't just turn down slowly, but it'll snap to the next level. And you can see
Yeah.
those snaps happening as this next level of this pattern. And
Yeah.
this is the picture I saved because I got from him such a long time ago. But this is the start of it. This is the one that helped me to understand what was going on, and that mountain building was happening through different forces than what we've been taught. And it's not all mountains. This is just some, you know,
Yeah.
and it's only in certain places where these supersonic winds have happened. But yeah, this was one of the big ones for me. Let's see. So it opened my mind to that, and waiting for another chance to go to the Electric Universe and tell these guys about it, about what I've discovered,
Yeah.
just never happened. And so
Right.
I've been looking at other places, you know, trying to find, you know, I guess another community. Like I said, I don't do social media, so I don't know how to connect with these people on an individual level.
Right.
But I came across the Cosmic Summit in 2024, and a lot of the stuff that they were doing at the Cosmic Summit is right up my alley, because the ancient civilizations, I think, are absolutely true. You know, how these things are even I how mainstream science, how can they even deny it? There's so much evidence that there was a larger civilization on this planet, and they still say the pyramids were built 3,000, 5,000 years ago, when it's obvious they were built 12,000 years ago, or older, at least 12,000 years ago. That the great catastrophe that happened 12,000 years ago to bring an end to the Younger Dryas
Yeah.
is what knocked that civilization back to the Stone Age. So our civilization that we're in right now did not start there, where we were hunter-gatherers and eventually worked up to doing a little bit of agriculture to where we can make larger villages and towns and come together. No, we were thrown into that, and we are the survivors. We are not the first time that an advanced civilization has ruled this planet. We are the survivors of that, and
Yeah. Yeah, that's very
as far as
fascinating in terms of like, the advanced civilizations that lived before our civilization, right? There was this whole like, the Younger Dryas impact, and the people that were living at that time, and then you go back to like ancient Egyptian times in terms of the knowledge they have, and we still can't figure out how they've built this bloody pyramids, right? Imagine how much sophistication we have today. No one can tell us how these bloody pyramids were built, and now they're talking about these large pillars that exist underneath the pyramid to a scan, right? It's like that's the beautiful thing about these sort of like big events. It's like, why are they happening? Why are we here? What's the purpose? What knowledge was lost and what knowledge was sort of recaptured, and the revisionism that's happened in mainstream science in terms of what's happened in the past, and how much we know, and the archaeologists and how they control those information is also very fascinating.
Yeah, archaeology and mainstream. I can understand the theory I told you about being a physicist in a research lab and going to your donators and telling them you're doing it wrong and you want to try something different. You're afraid of losing your funding. But for the archaeologists to hold things back because it changes the narrative of their
Yeah.
stories, that's ridiculous. I don't understand that one at all. Why would they want to hold on to that? And I got a couple of out in left field theories about why they're doing it. One of them is I actually wrote a story about a science fiction, story, not
Yeah.
not real theory or nothing, but it kind of holds true to possibly why, this great catastrophe that happened, and we all pretty much agree that there was a great catastrophe. Something happened on the earth. The Noah flood. Every civilization that has enough technology or is advanced enough to be able to hold on to stories from ancient times has a flood theory, has a flood myth.
Yeah.
How can that be unless there was actually a giant catastrophe that happened? And that catastrophe, there's just a lot of evidence to show that it happened. And if we take something that we have found that might give credence to it, why hold it out? Why hold it back? Why not let everybody have it? Things like the pottery shards, the pottery from. I'm so terrible with names, but the guys who have the pottery and they're doing the measurements on it, showing that this is such sophisticated machinery to create this pottery. And I don't even know if it's right to call it pottery because it's carvings out of solid stone. It's not made from clay, but
Right.
they're just incredibly thin, so thin you can shine light through them, and
Yeah.
absolutely perfect and smooth.
Yeah.
The Bora Bora caves, the walls of the Bora Bora caves are so incredibly smooth. They're as smooth as the glass in the windows of your house. And
Yeah.
these are rock.
Yeah.
And they're
Isn't
saying
that
they were
the
cut from
same thing that
stonefish.
was on the Pyramid of Giza, the shiny bits that they built, and then the Egyptians over time stole the stuff off the pyramid to kind of use for other things? Isn't that the story?
Well, that's the mainstream story, but is there another story? Is there another way that this stuff could have been torn off the side of the pyramids? I think there is. I think if a wind came through there at thousands of degrees, there's vitrified stone all over the place around there, and there's signs of melt.
Yeah.
Darren Kuyu, wait, no, Darren Kuyu are the caves. Doggone it, the name escapes me. But there's a place where there was these giant statues, and these giant statues were just strewn about like a child came through and had a tantrum and knocked all these giant statues over. And there's burn marks on these things. It's almost a rubble strewn field, and a strewn rubble field that has burn marks on all these where it reached thousands of degrees. It vitrified the stone on these statues. So something came through. Could that have been a super hot, super fast wind that would have destroyed this whole area and knocked all these statues around like child building blocks, just knocked them over and pushed them around? Could that wind have gone by the pyramids and torn those nice polished pieces off of the surface of the pyramid and strewn them about? And people picked them up not from off the pyramids, but from laying around because they were knocked around, and they used them there. I think that the technology of the time, people getting up to the sides of the pyramids to get these blocks off, is kind of unrealistic. Some of these blocks were pretty big,
Yeah.
and
Yeah. Yeah. Yeah.
people climbing up there just to get a stone that they could have cut from somewhere else a lot easier. I don't think it really holds water, but if it was knocked off, yeah, they used them. They picked them up from lying around.
Yeah. Yeah, it's interesting. Like, I talked to Ricardo Calvario on my show about stone technology and the ancient civilizations and how good they were with stone, carving stone, blocks, transportation of stones. And so much of that is sort of lost because we don't really do much with stone, right? And I do commend people who take different paths with science, instead of just following this, what everybody else does. I was very much, excited when Elon Musk decided to not use carbon fiber technology for building the Starship, the biggest rocket in SpaceX, and decided to use steel sheets. And that was really fascinating too. And he talks about it in his book, and why he did that, and the physics behind how steel is, a better option for building rockets. So I really find those sort of decisions moving away from science as we know and as we use it, but trying new things and new materials and new engineering feats. So there's an interesting sort of weave in history on how we've gone away from using different materials and the science that we've learned along the way.
Yeah, yeah, we're a smart folk. I mean, we're doing a lot of stuff out there that 20 years ago were thought science fiction.
Yeah.
And we're not using a lot of new technologies to do it. We're just using what we already have, and yet there's a lot of new technologies coming out that are making things easier for us. So yeah, it's a changing world. It's a fascinating time to live.
Yeah, it is. It is.
So I should move this along, huh? We got to get into cicatrix.
Yeah, let's do that. Yeah, we do. I mean, I think we're building up to your work in the cicatrix. Let's get into that.
So I had a presentation, but since I went from MacBook to a PC, I have not been able to get my presentation to work. So all I have is a bunch of pictures. So I will try to do my best to give you the story of what happened and why I think it happened. I first, well, come on. I'm so used to a Mac now. I'm trying to get back into using a PC. Okay, so this is the scar. This is Sutton Cicatrix, and it's one of these things that I tell people that once I tell you what this is, you will never be able to look at this part of the earth the same way again.
Yeah.
I mean, it's just it's that deep. And I'm wondering if I can try Google Earth here real quick, because I can
Okay.
get way more into this with Google Earth. Okay, oh, means I got to change the screen now. There we go. You see the Earth?
Yeah.
Get rid of all this stuff. So I love looking at Google Earth, but I love looking at it just plain, with nothing. Nothing. You know, it's just the Earth.
Yeah.
No indication of mankind at all. So over here, now mainstream geology tells us that India is a subcontinent that crashed into the Eurasian continent, pushing up the Himalayan mountain range.
Right.
And raising the Tibetan plateau here.
Right.
So if you can imagine this subcontinent coming in and crashing in here, but it when it raised the Himalayan mountain range and did all this lifting up of this whole area, the Tibetan plateau, why didn't it do anything on this side? This is pristine and
Yeah, sort of like a ripple effect, right? If it's crashing into it, then there is a bit of a blowback.
yeah, there should be some on both sides, you know, unless this is such a strong continent and this is such a weak continent. But I've never believed that. I thought it just doesn't make sense.
Well,
So
I mean, isn't the theory that all these different continents came together gently and gradually over many, many, many thousands, maybe millions of years?
millions
It
or
wasn't just
billions of years.
it wasn't just like a like a bump into each other aggressively, was it?
Well, that's what mainstream science tells us. Continents move at about the speed your fingernails grow. And
Right.
and
Fingernails grow very fast. So if you apply that speed to a large continent, that's moving very fast.
well, in a way, yeah, but it's also moving very slow. It takes a long time for a continent to move all the way across the ocean. You know, we have
Right.
South America and Africa here. It looks like they used to be together, you know, And there's quite a bit of evidence to show that there are things
Oh,
here
yes.
and
Yeah, they look
here.
like they used to be together. They're
Yeah.
just perfectly carved out.
You can see how Africa would fit right up in here, and how this
Yeah.
would have come together. So they think this was all one giant mass called Pangea. It was one continent on the Earth called Pangea,
Yeah.
and it was split up. And this is the Mid-Atlantic Ridge that is what they think is the crack mark where it split up from.
Yeah.
And these two continents, or two halves of the world, started drifting apart.
Yes.
There's a guy, Dr. Brown. I can't remember his first name, but he has a theory called hydroplate theory,
Mm.
where something happened that created this crack, and these continents flew across the ocean at freeway speeds.
Mm.
And when they started slowing down, they flew off, and it's called a hydroplate. Hydro meaning water,
Yeah.
because or liquid, because the continental plates sat on top of a layer of water.
Mm-hmm.
And even in the Bible, when you talk about Noah's flood, they said the earth split apart and water came from the deep to
Mm.
flood the earth. It wasn't just 40 days of rain coming from the sky, but it came from the deep because it had never rained up until that point.
Yeah, yeah, yeah. I mean, it's kind of interesting as well with New Zealand. And if you look at that area, there was like a continent called Zealandia, which is most of it is underwater today, leaving the North and the South Island sort of on land.
Yeah.
Yeah, where you're pointing at, that's sort of like the entire continent of Zealandia, which is underwater.
And this whole thing could have been above above water not too long ago. Well,
Yeah,
before the Younger Dryas, because the sea level was, what do they say, about 400 meters lower than what it is right now.
yeah.
That's a
How
lot.
much did the Younger Dryas impact, based on theory and hypothesis, and peer review science, shifted the world map? How much did it really kind of move things around?
That I don't know. I honestly don't know what they think happened.
Yeah, yeah. But
Yeah.
I do know that wiped out almost the entire population in that sort of North American region. I understand that's where the sort of the main impact was.
Well, I have a theory that kind of brings the solar outburst theory and the impact theory kind of together. I don't think it was
Yeah.
just an impact. I don't think there is.
Yeah. Okay.
I don't think there's something out there with enough energy to impact the Earth and do the damage that they're saying it did without
Yeah.
destroying the entire planet.
Yeah.
Because the damage is everywhere. It's all the way across the planet. So it'd be hard to have a single impact that would create that kind of devastation all the way across the entire planet. You
Yeah.
will find impacts because I believe things were thrown up into space and they came back down and created
Mm.
impacts all over the world. So with this hydroplate theory, one of the things they think is that if this continent was shooting across the ocean at freeway speeds, as it slowed down, or as it moved off the water and came and started striking the solid ground underneath, you would have mountains creating as this part of the continent basically came grinding to a halt. So you see it's coming across and it's gonna as it's skitching across, it's doing fine, but as it comes down, it hits, and you're gonna have mountains build as it comes to a halt. And that's why we
Yeah.
have mountains all the way across the western side of South America, and even across
Mm.
North America, you have mountains across the side. And the larger scar here is something different. So it's
Mm.
two different scars you're looking at. One of them is an electrical scar, but the other one is like the Cascades in the Sierra Nevada
Yeah.
has been created because of the continents coming to a screeching halt while
Yeah.
skipping
Yeah.
across the ocean or the water
Yeah.
level. And then
How
things on this
scary
side.
is the? Yeah. Sorry. Go ahead.
things on this side, as they come to a halt, they're going to have a little more momentum. So they're going to build up a little bit also, but you're going to have more long, flat mountains, which is exactly what we find on this side of the American continent, is these more,
Mm.
you know, and something like this, you can even look at it. You can see the lines where you can see it kind of came together and squished and buckled. And I think it was momentum that caused these buckles here,
Yeah.
as this was still on water. This part here was still on water, so still trying to flow free. So it kind
Yeah.
of smashed up a little bit. But that's Dr. Brown's hydroplate theory, and it's very fascinating stuff. I mean, as far as having momentum, you'll have a lot of areas like this where momentum from the continent is going to push up some of these small hills all facing the same direction, and yet massive mountains on this side because it was coming to a halt over here. So
Mm.
it's a fascinating theory.
It is, yeah, yeah. I
Not a
mean, how
lot out there.
fascinating is the electrical scar on Mars, that long one? Do you know what the one that I'm talking about?
Yes, Valles
That is,
Marineris.
yeah, that is just like wow. That is a very big scar. That's an insane scar. That must have been some very powerful electrical discharge from the universe.
I believe it was. In fact, if I go to that, can't where yeah, there you are. So this is how I met Brian Corey Dobbs. We were at Cosmic Summit 2025, and I had on my computer this image of the Earth and this shape here, and I compared that to, and I'm gonna share this now. This image, how these two come together, and I wish I could do this using my presentation because it's a lot better. But this picture still shows the same thing. You can see how this is Valles Marineris on Mars, and it's just a picture. It's not anything that's been manufactured, so it's not something that some artist rendition put together.
Yeah.
However, the background obviously is artist rendition, and you can see the size of the planet being the same size as the Earth. So
Yeah.
I've blown up the image of Mars, so it's the same size of the Earth, when Mars is actually a lot smaller than the Earth.
Yeah.
But when you blow it up to this size, you can see Valles Marineris is a huge scar across Mars, and yet
Mm.
Western Washington or Western United States or North America, all of North America, even on the way down into South America, it's the same scar. And there's
Mm.
things like right here is Yellowstone. Yellowstone is right here. It's at the center of this scar.
Wow.
Things like it goes up here and arcs this way. Even the archipelago here is a circular shape here. As it runs
Yeah.
into Central and South America, it goes up this way, just as it goes up this way. So it's the same scar. You have a bulge out here, you have a bulge out here. Even the Gulf of California, or the Baja Peninsula rather, is represented here. It's the same thing happening. Because this is a much smaller planet, you have this little scar here, which is like an anode and a cathode between these two sides. You also have up here the Badlands and the Black Hills in South Dakota. These two items are anode and cathode from an electrical scar. So it is an electrical scar. I mean, you can see it runs up here, it runs up here. There are just so many similarities between these two scars. It was created by the same object, the same thing that did Valles Marineris came across Earth and did this to the Earth. And there's a lot of different theories of what that was. A couple difference from Manuel Velikovsky, Worlds in Collision, how Venus entered our solar system as a comet, as a charged body. And as you have two different bodies of two different electrical potentials, as they come closer together, you're going to get a spark because they're going to want to equal out this electrical potential. So as one
Yeah.
body crosses the other, you're going to get this spark that would create this image that we're seeing on both planets. Obviously, it was I think it came across the Earth first because the damage that it did here, it discharged some of it, so now it's not so doesn't have so much of a difference. So when it went by Mars, because Mars is such a smaller planet than ours, the scar is going to be roughly the same size on Mars when you blow it up to the size of the Earth. I don't know if you're following me on that, but
Yeah, you know, I've never seen this comparison, and it's very fascinating, and it's like so similar, and you're opening my mind to this whole electricity sort of activity that goes on in the world that we don't really talk about much. And
yeah.
how
So
much of
this shape here,
electrification do you think how much does electrification dominate the universe?
oh man, absolutely. I mean, it's so many things that are happening in the universe that we can see through our telescopes can be explained through electromechanical or electromagnetic forces.
Interesting.
A lot easier and simpler than they can be explained using gravity and these wild equations that these physicists pull out, saying that it's a lot easier to describe something with electromagnetic forces. And then stuff like this you have to give up to coincidence. You know that this is water erosion, and it just coincidentally happens to look like the western side of the Americas. And yet there's too many coincidences. I mean, too
Yeah.
many. The way these individual jets come out here and coming out here, it's the same shape. You come over here, there's another one here, there's another one here,
Yeah.
this shape here, and this shape here.
Yeah.
I mean, I can go on and on about how these
Yeah.
shapes
Yeah, I
represent
think
each other.
you know, like one theory you can put this down to the fact that, you know, there was a lot of electrical activity in our solar system at some point
Yeah,
back in history, that these similar events happened on Earth and Mars. And, you know, and that stuff doesn't happen anymore. Like, you know, there was, you know, you go back 2 billion years in Africa, in Gabon, there was a nature created nuclear reactor that
yeah,
was producing nuclear energy into the world, and that sort of, you know, operated by itself for thousands of years. But if you think about, you know, can that happen again? The answer is no, because, you know, those circumstances and those materials and those conditions don't exist anymore. So maybe there was a time that these conditions and these electrical sort of, like, you know, discharges were quite common in our history.
absolutely. And you struck the nail right on the head. It doesn't exist anymore. It doesn't happen on this planet anymore. And that's exactly what I was talking about when I was talking about the megalithic structures and some of the things that we're doing. We don't live in the environment now that we used to live in. The environment that used to be on the Earth was much more electrically charged than what we're in now. We live in a very peaceful, neutrally charged solar system now, but it wasn't always that way. Things were a lot different. And because of the electrical potential that we sit at now, things are much calmer. The storms that we have on Earth, the electrical storms, are nothing compared to what they used to be. But yeah, so absolutely. Oops.
What do you make of this whole, like, you know, I don't know if you've read Elon Musk's Master Plan 3. I think there's a Master Plan 4 now from Tesla, in terms of this whole electrification of the world energy production, and, you know, solar systems and batteries, and, you know, getting energy from the sun. Are you for that sort of thinking, or do you think that's also there's a lot of myths that needs kind of like breaking?
Well, as far as getting energy from the sun, yeah, we can do that. Solar is definitely a possibility. I mean, there's different ways to generate electricity that we haven't discovered yet. But as
Mm-hmm.
far as forcing us to do these things that are unproven, I don't think that's right. I think it's, yeah,
Yeah. Yeah.
dumping pollution into the Earth's atmosphere is wrong.
Right.
And whether you believe in global climate change, global warming, global cooling, or whatever, uh, it doesn't matter because the crap that we're throwing out into the atmosphere needs to be cleaned up. I completely agree with you on that one, but I just don't think we need to be forced into doing certain things that are unproven,
Right.
like these wind generating. I think wind generation is a great idea, but using these giant windmills that they have, these giant blades that slice through the air like that, they create more damage. I mean, it's very rare people are talking about the amount of birds that they kill as
Mm.
these things are flying through the atmosphere. I mean, there are places where there's so many birds that were killed. It has changed the chemistry of the ground around them with all this animal matter being dumped onto it. It's changing the chemistry,
Right.
and and it's just not good for the animals. Yeah, and they're dangerous. They can come apart. So there's other ways to generate electricity from the wind, rather than using this what I still see as a very archaic giant windmill. But that's another story.
Yeah. 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 Yeah.
So we're
This is fascinating, man.
so that's how Brian Corey Dobbs and I met. He came. It was Ginger. His girlfriend was looking over my shoulder, or he was talking to her, and a pilot was with his girlfriend. So I was talking with the three of them when Ginger says, "Hey, I've got somebody that needs to see this." So she went and got Brian and brought him over, and he was so fascinated with what I was doing just between the Earth and Mars, because he's the Mars guy. I mean, he's all
Yeah,
about
he
it,
is.
and he hadn't he's heard of this before, but hadn't seen the amount of detail that I was showing and bringing about, and he wanted to talk to me more about
Mm.
this, about the Earth Mars similarities between the American continents and Valles Marineris. But when
Yeah.
we got talking more about it, I was telling him more about how this is somebody else's theory that I just kind of built on. But my theory was this, and I started talking about cicatrix and the scar that I found.
Yeah.
And he was so fascinated with that he ended up putting out the documentary film about Sutton Cicatrix. And
Yeah, I saw that. That was really cool. He's got such a great way of kind of like breaking down these things too. He's got his own unique style, and if you haven't watched Blue Planet Red, you have to watch Blue Planet Red because it's on Amazon around the world, I think. Now
yeah,
it's
it's quite a few places.
it's just an incredible documentary, and so much of Mars is dominated by Elon Musk and SpaceX, and I think Brian Corey Dobbs done a great job of like bringing a very new perspective on understanding Mars and microbial life and ancient history and
Yeah.
so much more.
Yeah, he's really opened my eyes. I mean, I looked at this Mars stuff and I thought, oh, yeah, there's all kinds of stuff. The face on Mars, there's some anomalies on Mars, but I never really thought too much about it. But
Yeah,
after watching Blue Planet Red, I am all on board. There's so much stuff going on. Uh, and yeah, great documentary. So here's a little interesting sidetrack tidbit. Uh, so I live up here in Western Washington, but down here in Eastern Oregon, there's this desert. And, you know, I don't know what draws me to this, but this is the Alvord Desert in Eastern Oregon and Steens Mountain up here. Part of the thing that started me on this was going to Alvord and just hanging out in the middle of the desert, because there's nothing cooler than just being in the middle of nowhere, and and miles where you can see it. And I gotta bring this down real quick. But Alvord Desert. So if you're looking at Blue Planet Red and you see the woman dressed in red with the black across her eyes, and that whole portion of the movie, Blue Planet Red, was filmed in the Alvord Desert.
Yeah.
So just as a one of those funky weird coincidences that just kind of blew both of our minds when I started talking to him about how this kind of started for me here in Alvord, because of the Steens Mountains that I found next to it, searching on Google Earth. And so this I guess I'll give you this side of the story. This is kind of how Cicatrix was found. It's on Google Earth. After going to Steens Mountains and hanging out, or going to Alvord Desert hanging out, and then I looked at Steens Mountain, and I saw these lines running this way. So this is called what they call an uplift. It gradual slope down this side and a steep slope down this side. They're saying this is like a crack in the earth that was pushed up, and it's geologically it's called an uplift. So on the leeward side of this uplift were these crazy lines running against. You can see the sedimentary layers are running this way all through this, but then there's these lines running this way against the sedimentary lines. So and they are perfectly straight. These straight lines running through here, and it just kind of blew my mind. And it's another one of those things that's like, how do you explain that? And so looking at it a little closer and trying to figure something out, what caused this. When I zoom out, you can see the arc has a bit of an arc here. When I zoom out a little farther, you can see there is a circle. And I thought, what the heck is this? This circular shape that I'm seeing.
Mm-hmm.
So if you look right over here, so you see this circle here, this down here is Yellowstone. And in Yellowstone, you have these other circles here, here, here. These are ancient calderas from the supervolcano that is Yellowstone, the Yellowstone supervolcano.
Yeah.
And I thought, well, if there's a caldera here, these ancient calderas, and what I'm looking at is up here, and I lose it sometimes. It's just hard to see sometimes. But here, the circle. Maybe this is an ancient caldera from the Yellowstone eruptions. Maybe this is a super volcano, and it's so much bigger than these other ones. I mean, I thought, hey, maybe I have something here. And that's when I started looking at the mountain building in this area and learning more about it. And that's when I stumbled across Michael Steinbacher, who had different ideas about mountain building. And from there, I learned the electric universe. And Andrew Hall, who talked about these arc blast patterns. And I've always been fascinated with this part of the world and this teardrop-shaped desert, because it just looks like something happened here, like something came by and grazed across like a giant asteroid or something, and just a sketch. It wouldn't have crashed it. It would have just been a grazing hit as it came by that created this shape. And I thought maybe that's what it was. And so I started learning more about impact and what happens during an impact. And it turns out that the energy when a body strikes the earth, the energy that's released during the impact and the inertia that these things carry when they bring in, the amount of inertia that they're carrying with them is nothing compared to the energy that's released, which is why most of these craters we find all around the planet, all around Mars, Earth, Moon, everywhere, they're round. They're round because the energy that's released during that impact isn't really affected by the inertia of the direction that they're coming in. So they could be coming in at a glancing blow, they could be coming in straight down, or at any angle, you're still going to have a round crater because that energy is so much more than the inertia. So it's not really going to affect it. So that's how I learned that this shape, there must be something else. Because if it was something impacting, even just a grazing blow, it would be a round crater. And if it was something big enough to create this big of a scar, it would have been planet killing. It would have destroyed our planet. But after looking at Andrew Hall, when he was talking about mountain building being these diamond patterns, and I started looking over here, what I would call as being downstream of this, in this area where you can see this whole area, it just looks like, fluid dynamic patterns of ejecta landing here. And like you just took a bucket of slurry and dumped it across a flat panel, you're going to get this sloshing shape. And I thought, well, if that was the case, then you would find these diamond patterns down here. And as I started to look at this stuff, I found them everywhere. This whole area, you can't go anywhere in this part of Iran without seeing these diamond patterns. You can just zoom in anywhere. And you see these diamond patterns, these arc blast, supersonic winds creating mountains. They are just absolutely everywhere. And these are so easy for me to see. I don't know if you're seeing them like I do, but these diamond patterns that break down into smaller, larger and smaller. So here's a good example there. You can see the larger ones, smaller ones, even smaller here. This whole area is just covered with them. I mean,
when this was quite normal in our history, how much do you think these sort of like discharge shift and change societies during Ice Age, lost civilizations, sites like Göbekli Tepe, appearing right after the Younger Dryas? Do you see sort of like relations between this and how life may have adapted or changed or shifted?
Well, yeah, I think that first of all, that this would have wiped out much of the civilization on the earth. This would have killed just about everybody. I think we just barely scraped by to reach the point to where we're at now with the population that we have now on the earth. And there would have been places where nobody survived. Like this whole area here, you're not going to find anybody that's going to survive this. It's only going to be people that have repopulated this area, came in from other places that survived. You know, and I'm thinking this whole area. So yeah, I think it's that's who we are. We are the survivors of this. We are. This thing did some real damage. So if it was, I mean, so much of this stuff, and I really don't want to say stuff that's going to step on people's feet, step on people's toes that have devoted their life to archaeology. But I think we need to find different ways of dating things. There's a lot of problems with archaeology dating stuff by looking at the layers of dirt that it was found in.
Right.
And you find a lot of circular references where people who are dating the dirt that they're in find what's in there, and they take the dates that the archaeologists say that this happened, and they say that must be the date of this layer of the soil. And
Right.
the people who are dating the archaeological artifacts are taking the date that the geologist found for the soil, so they're dating it to that soil. So you're dating one because they found this at the other, so they're saying that happened at the same time. And it's a
Mm.
circular reference. You know, carbon 14, carbon dating, they have found lots of problems with it. I believe it's pretty accurate, but not as accurate maybe as we think. And I think there are things that could have changed the decay rate of carbon 14. So there might be reasons why something would appear to be older or not as old, because of the decay rate, because of something has changed the decay rate.
Yeah.
And so I just think there's a lot more work that needs to be done, by a lot smarter people than me.
Yeah. 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 So what are you working on next? What's your sort of next research focus?
Well, I'm still trying to figure out how this happened. So when I talk about the scar and this whole area being cicatrix, that there is a pattern here. There is a line that runs this way. There is also a line that runs this way, and I found that actually, well, I can't really put these things over one another. I have to go back to this. When I found and let's see, how do I do this? Oh, there we go. If I just do the screen. So this shape I found online, and when I laid it over top of what I found on Google Earth, it matched completely. And
Yeah.
I wish I had my presentation, because I overlay these, and you can see how the pattern of this shape here. Come on now. The Himalayan mountain range follows the arc pattern of this shape, which I believe is the shape of a plasmoid, missing the rod going through, but
Yeah.
still has the disc between it, and then the toroids on either side. And I think these toroids are counter-rotating, held together. It is a magnetic field. It is the essence of a magnetic field, a self-sustaining magnetic field. And as I laid that across the Earth, I found that the Himalayan mountain range followed this pattern exactly. And that, I think there's one. This one here is a magnet sitting on top of a ferrofilm or ferrolens. So you're seeing
Yeah.
the magnetic field here. And again, this shape here exactly fits over the Himalayan mountain range. So it can't be, let me get rid of this. Too much stuff on my screen. It's more than just a coincidence. And that's why I found, as this is a toroid, so you're looking at this as a three-dimensional image, you're looking at it in a two-dimensional, or a three-dimensional shape, you're looking at it in a two-dimensional image. This part here just being a bar magnet sitting on top of this ferrofilm, and then a single light underneath it revealing the magnetic field. The line on the outside is part of the aperture, part of the structure that was built to show this. So you could disregard this this line on the outside, because it's part of the ferrolens itself, not part of the magnetic field. But this is the magnetic field. The toroid on top, the toroid on bottom. So you're seeing the three-dimensional image of it. So this is going to be spinning. So this is moving up and this is moving down. this is moving up and this is moving down. So they're spinning these toroid shapes. So as this is spinning up, it's going to be moving anything because it's a magnetic field. And you have to understand the difference between magnetism and diamagnetic properties. Everything has diamagnetic properties, so it'll be pushed away from a magnetic field, and that's why this whole area has been raised up. You can see you can take measurements here. In fact, you look at this, see where you move your mouse, 16,000 feet, 16,100 feet. So this whole area is roughly, 15 to 16, 17,000 feet, this whole Tibetan Plateau. But over on this side, it's way low. What am I at here? 1,400 feet, 1,200 feet. Even up in these mountains up here, you're still only 7,000 feet. Down here, you're at 1,500 feet. So this whole area has been depressed down while this whole area here has been lifted up. And that's because of the spinning toroid that hit this. Lifted this whole area, depressed this area. And then on this side, over here, you can see this is, 2,400 feet, 5,000 feet. Well, it's smaller as you get farther away, 4,600 feet. But over on this side has been pushed down a lot, 1,200 feet. So I'd love to be able to get, in fact, I do have it, don't I? I'd love to be able to get a topographical map of the Earth. So is it this one? So you can just see it better here. This is the Taklamakan Desert, Himalayan mountain range, and the whole Tibetan Plateau has been lifted up. Well, on this side, this whole area has been pushed down. And yet on the flip side, on this side, this area here has been lifted up, and this area here has been pushed down. So it's easy to see with this. This is an artist's rendition. This is actually a work of art that you can buy for, putting on your wall. But it shows it. It shows the counter-rotating aspect of the toroid. And I don't see it on there. I have another image where it's I've laid these two images over each other, and you can see how they just absolutely fit.
Yeah.
There it is. So you can see this is the magnetic field, or that the bar magnet sitting on top of the ferro lens laid right over the Earth. So you can see how that lens exactly fits the Himalayan mountain range, or how this magnetic field line. And I guess the reason why it doesn't fit on this side so much, I can explain that by showing that if you're looking straight on and you want to make this mark, so I want to do is it a path? So this is the entry wound where it comes in. That's the center. Well, it's not working then. Clear, it's a line. Well, doggone you. Well, it kind of shows a little better.
Yeah,
But when you see it
yeah,
over
it does.
here, it's not straight. It's a curved line.
It is, yeah.
But when you
It's
show
quite
it
obvious though. That line's quite obvious.
yeah. So when you show it at an angle like this, where it wasn't a direct blow, it was
Mm.
a more of a it hit it at an angle, which is an oblique angle. But when you turn it off to the side here at about 45 degrees, you can see that line does turn into a straight line, as opposed to over here. Not a good representation. But again, once I get all this stuff moved over from my Apple, from the Mac, it shows it a lot better.
Yeah.
Then you can see this straight line. And I'm able to run that straight line all the way to the reshot structure. Which is not working right now.
Yeah.
Yeah, I got to learn better how to use this.
Yeah. There can be lots of glitches and issues but it's
Yeah.
amazing how you can use Google like Earth like that and Google Moon. You can like really get into it. Like you can zoom in and look at all the different structures and what's happened. It's really amazing technology.
Oh yeah. And I love it. My wife says I spend way too much time on this, and she's right. But this whole pattern, the double thyroid, which is how I found the disc that runs through, being this image here. And what was a real shocker for me is once I found this disc and the toroids, I found this X marks the spot, and I zoomed in on the X marks the spot, and I found Squatterman, oops, right in the middle of it. And this is the shape, this like Q-tip, which is the center point of Squatterman, which is the plasmoid, or I'm sorry, which is the high energy discharge in a plasma environment, will create this shape. That's why I think this was a plasmoid, because this being the exact center of both from where it came out, another entry wound here, and then a line that runs this way. This is a literal burn mark, which I believe is Squatterman. And I have a picture here of Squatterman that I got. This is Squatterman, which is an high energy discharge. It's also a petroglyph that's been found all over the world, which is why I
Mm.
got some of these pictures over here. These petroglyphs that have been found on every continent
Mm.
that match what we're looking at here, that match this high energy plasma discharge. So I think that high energy discharge is found here, and it was burned onto the earth. I think that was the big aha moment for me, that this definitely was an electrical discharge
Yeah,
that
yeah, yeah,
pushed
yeah.
all this stuff out, burying the entire Middle East. There's a Herbig-Haro object that lays over the top of this. I also believe a Herbig-Haro object is a plasmoid, and it is we don't know what it is, so we call it a Herbig-Haro because it was discovered by two different guys, Herbig and Haro. And but I think it's the same thing. It's a plasmoid. It's also a black hole. I think a Herbig-Haro object is like a smaller representation of a black hole. Um,
Mm.
yeah, you can see this running all the way across here. So I think this had far-reaching effects by breaking the continent up, creating the two waterways here, and then continuing on and literally burying all of North Africa in sand. You know, they say
Yeah.
they don't know where the sand came from to create the Sahara. I think it came from inside the earth and was dumped down here.
Mm.
You can also say that a lot of the material was thrown all the way up into space because this thing hits the ground, it's spinning, it's going to be lifting up the Tibetan Plateau, and a lot of the material that came from here was thrown out into space. Some of it left the left Earth and is still out in space, and that might be the some of the asteroid fields that we go through. That we have meteor showers. What is it? Twice a year because we go through these orbital patterns of this asteroid field that we go through twice. Can't remember what the name of it is. Doggone it, I'm drawing blanks. But it a lot of them also came back down to Earth, which is why we have impact patterns all over the Earth from a lot of this stuff coming back down. Darren Kuyu is where we built underground. I think that was possibly because we needed a place to survive. If these rocks are coming down everywhere, it was killing people. It was a dangerous place to live for a while. And so that could have been why we went underground. It could have been why Göbekli Tepe was intentionally buried, because they wanted to be preserved. They wanted to wait for this bombardment to stop so they could go unbury it. And
Yeah.
unfortunately, not enough people survived, and Göbekli Tepe was lost in memory.
Yeah. That makes a lot of sense, doesn't it?
So it could have been buried not because they wanted to abandon it, but they wanted to preserve it so they could come back to it. So this is kind of the big theory of cicatrix, this plasmoid that I call Sutton Cicatrix,
Yeah.
and why, and I've given a very poor rendition here, and I apologize for that because I kind of frazzled with this new PC and not really having everything in place. But in the months to come, I do hope to put out more videos on the YouTube channel, the Sutton Cicatrix
Yeah.
YouTube channel.
Yeah, absolutely. What's your YouTube channel called?
Sutton Cicatrix.
Awesome.
So at Sutton Cicatrix. I've also got a website, suttoncicatrix.com, which right now all it does is direct you to the YouTube channel. So eventually I'll put stuff on there. I want to put things like, links to this kind of stuff, to the podcast that I've been on. Links to Brian Corey Dobbs and the video that he did. And he's got some other stuff that he's putting together as well. He says that he's going to be releasing eventually some more of the filming that we did when I was over there.
Yeah, I mean, YouTube is where I go to get most of my information about these things, and Brian is really good at YouTube. He's got, lots of great videos, big sort of community. He's got, I think, about 10,000 subscribers. He's helped John Ward set up his YouTube channel as well. Yeah, definitely. Yeah, that's the way to go. And just like, one video a week is plenty to just kind of like break down. You can kind of have a bit of systems thinking in your editorial strategy, in terms of like, take all the knowledge you have and break them down into a series of videos, and then you're kind of doing them. You can to keep your subscribers engaged. You can like, create excitement and premieres and launches and do a series on something specific, and then you could go into more generalized random videos once a week. So you can have fun with it, in terms of like creating that content and getting people engaged, and script writing is also something, podcasters are starting to do now. They're kind of coming up with script writing to rehearse how they're going to talk to a guest and how they're going to go through the storytelling. You have this sort of like, structure of a book you read or a documentary you watch on Netflix, where you have a hook, and the first 20 minutes there's a host and a guest, and there are characters in this episode of a podcast, and you have something exciting happening, and people know that there are characters, they're playing this in this world, that they exist. but they're not quite too sure what the full story is. And by the time they get to the 40 minutes in the podcast, they kind of have a really good understanding of what's going on. That's kind of like the punchline moment. And then they enjoy the episode for the rest of the episode. So you kind of have to think about that, kind of creating your videos with how filmmakers go about creating their videos, and that's how they kind of keep the audiences engaged throughout your videos. So it's quite fun once you get into it, and you're not only doing the science thing and commenting on your science stuff, but you're also doing a lot of, like, filmmaking type decisions and choices, which I think is quite fun to get into as well.
I'm really looking forward to it. Like I said, I'm retiring in just a few weeks, and I'm really looking forward to taking this on full time and
Yeah.
really putting some stuff out there. Right now, I haven't got anything on my YouTube channel. It's the one video that I have on there. I did when I came back from Cosmic Summit 2024, when people said, you've got to get something out there. So it's me standing in front of my TV set in my living room or in the den, and just going through the presentation that I put together on my MacBook, and recorded it on my cell phone, and then uploaded it. There's no breaks, there's no edits, there's no nothing. It's just 44 minutes of me standing there gabbing.
Yeah. No, it's great. No, this has been very fun, and it's opened my eyes to this whole plasma world, and electric discharge, and electricity. It's a fun subject. It's been really good fun. I think it's a good time to kind of wrap this up. Is there anything else you wanted to cover in this episode?
Well, just maybe some things I'll be coming out with in the future. Like I said, my theory on how megalithic structures were put together. These what do they call it? Things just pop out of my head. Names of people and things. The walls that they put together. The walls that looked like they were melted together.
Yeah.
I think I have a theory on how that was done, and why we won't be able to do it again until we develop new technology to bring back the environment that we had at that time.
Yeah, that sounds like a fun video.
Oh yeah, I think when this happened, when Cicatrix happened, when the plasmoid struck Earth, I think it went inside our planet and resides in there now. I think it's still sitting inside our planet, and being there, I think it turned our gravity up. So I think we're sitting in a gravity environment now that we have not been in before. That our gravity is a lot more strong on this planet. I think that's the reason why the megafauna was all wiped out at the same time at the end of the Younger Dryas. It was because the gravity was turned up. There is a gravity problem. You can't have dinosaurs on our planet now because Jurassic Park wouldn't work because these dinosaurs can't survive on our planet. They're too big. They'd crush under their own weight. African elephant is about the maximum size you can have on this planet right now. But what if the gravity was a lot less? What if the gravity was you could have these things. So it's, and I go into possible theories for what else this plasmoid did as it was bumping around our solar system, and I've come up with a path that it may have taken, and some of the damage that it may have done. So it's more things that I'll be getting into, and I'm really hoping, I would love to go to Cosmic Summit and present. I want to put together a nice tight presentation and bring out some of this new stuff that I have, some of this new evidence that I show.
Where is that happening? The Cosmic Summit.
Well, they don't have a date for it yet, and
okay.
I'm actually meeting next week with George Howard.
Okay.
He's the guy for Cosmic Summit. And,
okay. That sounds
I'm
exciting.
meeting with him.
Where is it taking place?
It's in Greensboro, North Carolina.
North Carolina.
I guess at the same place that it's been 24 and 25,
Okay.
which is a great place. It's a good hotel, lots of big rooms that we can meet in. We can have several different things going on all at the same
Workshops
time.
and
So it worked really
yeah,
well.
yeah, yeah.
And it's a nice place.
Yeah, that's
Yeah.
awesome.
So I'm hoping that, I guess they're trying to find supporters, um, advertisers, things
Yeah.
to help put it together.
Yeah.
I really hope he's successful with that because we need these things. We need these conferences. We
Yeah.
need these places where
Yeah.
people can come and meet.
Yeah, no, it's amazing. Well, I look forward to it, and you're welcome anytime back on the show. I think if you've got new stuff, just flick me a note, and we can get you back on the show. And I love having my guests to be regular on the show, so we can
You bet.
have you back. And I've had Corey twice now, and I'm sure he'll be back soon. And there's always new stuff to talk about, and new videos and new discoveries, and it's
Yeah.
about just keeping it fresh and regular and constant, really. That's kind of like the way. You just got to have a very aggressive output of information, and finding ways to getting information out to people,
Yeah.
in the earlier phases of discovery, and then evolving that discovery through those new videos, and letting people on that journey much earlier, and engaging them on your comments and your videos, so no, this has been fun, and we look forward to having you back.
All right. I'd appreciate that. I'd love to come back. I know this was kind of frazzling for me. I'm not used to it. Plus, I was kind of unprepared because of the new computer and getting things set up.
No,
But
it's fine.
and
It's great.
I'm kind of a frazzled personality to begin with. So
Yeah, I think no, it's people enjoy on the show, like everyone that it's everybody comes with different personalities, but people are really tuning in for the information and getting to know people,
yeah,
and I'm sure when you do more episodes, it's just gonna get much more smoother and flower. Even when I take like a break from podcasting, even like 1 week break, it takes me a little bit to get back into it. You just kind of
yeah.
have to, like, don't be too harsh on yourself, because these things take a long time to get really used to, and get in the rhythm, and get a good feel. So hopefully this experience has been a good learning experience as well.
It has. I appreciate you bringing me on and
Anytime, man.
helping me get this out there because I really believe in the Sutton Cicatrix. I believe the Plasmoid. I believe I have enough evidence to back it up. It's not something that I've picked out of theory, but I've followed evidence and
Yeah.
put it together. So I really think it's true.
Good stuff, man. All right. Well, bye, everyone.